Okay, today's lesson is going to be in simulation. And today we're going to flip 200 coins. Now, generally, when I go to flip coins, I like to do it on the soccer field. So let's go there where I can best flip my coins. All right, here we are. So let's start with our coin flipping exercise. We will flip, we will catch it, and we have a tails. Flip number 2, tails. Flip number 3, tails. So we've now had 3 tails in a row. What do we think the odds of the next one being tails? Let's make sure. Okay, we got heads, we have tails, so we do have both sides. Let's see what this one is. Once again, tails, 4 in a row. So what are the odds of this one being tails? If we've had 4 in a row, statistically speaking, the next one should be 50%. That's correct. We have a heads. Coin toss number 6, heads. Coin toss number 7, heads. Coin toss number 8, heads. Coin toss number 9, heads. And coin toss number 10, tails. So actually at the end of 10 tosses, we have 5 heads and 5 tails. They came in very strange spurts. We had 4 tails, then we had 5 heads, and then we had a tails. So we actually ended up 50-50, which is what you would expect overall. But in a small sample, it throws it off. So you need more data to get what your expected result is. So let's do another several tosses here. Heads. Heads. So at the end of the first 100 tosses, we have seen the result of heads 61 times and tails 39 times. That means if we were to continue going, we would expect to see the heads come up at a rate of 6 out of every 10, which I don't believe obviously is the case because of what the simulation shows us. So trying to do this, again, with limited numbers, the less data you have, the less accurate it is. Let's see what happens if we go to 200 tosses. And, now that I've been roughing in this shirt for a while, I think it's time I change my uniform. All right. Toss number 101. Heads. Tails. Number 200. Tails. All right, let's go tally up the results here and see what happens. And while we're doing that, I'm going to go ahead and switch back into my work clothes and get back to campus. With our second group of 100 tosses, 44 times it came up heads and 56 times it came up tails, which brings our total for the 200 much more in line with what we expected. Let's take a look at the result breakdown from 10, 100, and 200 tosses. At the end of 10 tosses, we had 5 heads and 5 tails, giving us a cumulative percent of 50% for heads and tails, which is what we would expect given the number of decision variables and the potential outcomes of each. At the end of 100 tosses, we had 61 heads and 39 tails, giving us 61% heads and 39% tails. And that is not what we would generally expect in a simulation. But again, the fewer observations you have, the less reliable and statistically significant your data is going to be. As we got to 200 tosses, you notice we came back into line a little bit, although not all the way. Let's take another look at flipping 200 coins, but this time we're going to do it with a group of people. Now, as you notice, that simulation went a lot quicker because we had many more people doing the work, but it still took a little while to get to 200 observations. And once we tallied everything up, you notice the percentages are coming in. They started off drastically in favor of heads, and they slowly worked their way down and then kind of hovered around a certain area and moved up a little bit between each round of 20 coins. And I would anticipate that the longer we go, eventually it would get closer to that 50% range. Now let's take a look at what happens if we do this in Excel. All right, so now let's take a look at doing this in Excel. As you notice, I have 10 observations over here. And the first 10, as you can see in B1 through B10, I'm getting 5 heads and 5 tails. And that's based on the formula in the A column. And that formula is a simple random formula. Let's take a look at it. There you can see the formula equals random, open, close parentheses. And it's going to give me a uniformly distributed number between 0 and 1. In the B column, my formula is very simple. If the random number is less than 0.5, I want it to return the value of tails. Otherwise, I want it to return the value of heads, and that's what I have. Now, as I go through right now, if I do any changes to any formulas or type anything else in, my numbers are going to change automatically, as you see. What I'm going to want to do is lock down my numbers and then only calculate them when I'm ready. So I'm going to go to formulas. I'm going to go to calculate options. I'm going to click on manual. And now, in order to maneuver these, I'm going to have to do an F9 on a PC or a function F9 on a Mac. And then it will calculate and change them every time. So let's take a look at the first 100 observations. If you were to go through and do 100 observations, you would notice we have 52 heads, 48 tails. There's a difference of 4. And the percentage difference is a mathematical, just a difference there of 4%. Now, if we were to change the formula here, and instead of counting through the first 100, count through the first 200, I'll change this to 200. And I'll change this to 200. So now we're counting. And as you notice, we have 102 heads and 98 tails, which is a difference of, again, 4 and 40%. which once again is the difference between 4 and a difference of 4%. Using that logic, I would assume if I counted between B101 and B200, we'd be even. So let's take a look at that and make sure I'm right. B101 to 200 as my formula for heads and formula for tails. I'm also going to change this to B101 to 200. And once I press enter, yes. So doing B101 through B200, as the formula says, gives me 50 heads and 50 tails, so there's 0 difference. Let's go back and count all of B. And that gives you the range of B. And that's going to give me a number there. And we're going to have to repeat that. Count if column B has a value there. So as you notice, now we have over 1 million observations. And as we get to 1 million observations, we might have a difference of 192 in the coin flips, but the percentage of it is 0.018%. So that's less than 2/100ths of a percent. The 10 observations we have here. Now I can go to calculate options. Again, because it's on manual, we can do that. If I were to click on automatic, then pretty much anytime I do anything to any cell, it's going to change. So I can continue to hit my F9 and keep looking how the numbers change. And you're going to notice in the 1 million plus observations, we're going to pretty much stay at the 50%, but in the 10 observations, that's going to fluctuate. There's a 60% difference there, 20% difference there. And as we keep calculating, the percentage is going to stay pretty much right around 50%. It might fluctuate down to 49.9, 50.1 possibly. But there you go, 49.9 and 50.1, it did it there. But the fluctuation is going to be very, very small compared to the 10 observations. Once again, this shows how many observations, the more observations you can simulate, the more reliable data you're going to have to give you an answer to the problem you're trying to solve. And could you imagine if you had to sit through and watch me try to flip 1,048,576 coins? Even if I had every student ever doing it, it would have taken forever. If you have any questions on any of these formulas, make sure to ask them in the next class.